Alright, hello everybody. Today we're gonna be doing making a electronic tripwire, I guess, with an arduino, a buzzer, and an ultrasonic sensor. So we're gonna build it first. So we got our little breadboard here. We got our Arduino Nano, and we're just gonna put that right into there. We're just going to line it up, press it down, make sure all the holes kind of fit in there. Ooh. There you go. Then we're going to put the sonic sensor we got right here. Woo! You see it has ground, echo, trigger, VCC. I might actually going to zoom in on this a bit. But yeah, no, we got that. We're just going to place it right here on the breadboard in those 4 holes. Now for the buzzer, we're going to put it in the top slot. You see the 2 pins. We're just going to do this one and there and plug it right there. Now we got to wire it up. So we got all these little wires and doodads. You're going to grab the first 4, 1, 2, 3, 4. Tear them off. And we're going to use each one of these to plug into the sonic sensor. So we're going to plug in the gray one up top. The brown one next. The white one. Oh, no, wait. What am I doing here? There we go. Gray, white, black, brown. Gray, white, black, and brown. And oh, yep. There we go. So all these lines, all these, for anybody who doesn't know about breadboards, these, when you plug something in, there's a little rail, electric, usually copper, maybe sometimes aluminum, but there's a rail in here that goes horizontally, and you want to anything plugged in horizontal until it reaches the center. Those will all be connected electrically. So that's there. So now let's try and plug in to where these guys go. We're gonna, so these guys are all kind of connected. The white goes to the first, or the gray goes to the first one, the white goes to the second one, the black goes to the third one, and the brown goes to the last one. And you can see, okay, so let's start with the brown one first. That's why they make all these different colors, so you know where you want to put them. Let's put this in, I don't know, where's the ground here? Ground is right there. And the next one's echo and trigger. Alright, the next ones are echo and trigger, not echo and trigger. So you want to have these plugged in. And we're going to do maybe 11 and 12 on this. So these pins right here should go there. And then the gray one, which is your VCC, that's going to be 5 volts. So let's look at the 5-volt section right there. There we go. So this is what it should look like with the sonic sensor hooked up to it. The next thing is going to be our little buzzer. So what we're going to do there is, you see the plus sign up there? We're going to attach that. Attach that. And we're also going to go 1, 2, 2, 3. There we go. So we lined it up so the pins here are going to be the same ones that these are going to connect to. So the orange one, we're going to go to ground again. That can share that pin because it's all the same ground. And then we're going to go for 3. Hopefully that's, nope, that's not 3. Is that 3? Yeah, that looks like 3. And so this is what it should look like. This is what it should look like when it's all wired up. Alright, so I guess now we're gonna... that was 7 minutes of my time. Now we're gonna plug this in via the cable to USB and hope that I have Arduino installed on here. So this yoink goes there. And then there. Are we lit up? What's going on? What do we... Oh, is this a dead board? Yeah, I might have grabbed a dead Arduino. That means I have to wire up another one. Not too bad. I have a bunch of them lying around anyways, so... not the worst thing in the world. Finding the right standoff pins might be a pain in the butt to do. There we go. Oh no, that's not the right standoff pin. This is all the behind the scenes things you should do before you... Okay, there's one. Alright. So we got one so far. The standoff pins, they come off separate. Most of the stuff I have here in here is going to be for... the Arduino, I forget what they're called, not the Pro. Could be the Pro. No. The Mini, I think that's what they're called. Yeah, I have the stuff for the Mini. Not for... There we go. A lot of minis, because I didn't know that they needed a special USB standoff. But anyways, we're here. Alright. Wait, let's make sure it works first. Okay, so the default code that's launched into these things is the blink sketch. Okay, so we got power now. And the blink sketch. So it's 1 second on, 1 second off. So we know that this one works. The other one, I'm just going to get rid of. We're going to toss it. We're going to do whatever we want to it because it's not working. It's a dead chip. Alright. Alright, next thing. Next thing we do is we're going to basically disassemble this board for a second. And we're just going to plop this one back on it. Let's either, let's get a better view of what I'm doing. Move it a little closer because I don't want to screw this up. I think it was 2 and 3 because they don't want to make this thing too even. What's going on? It should just fall into place, shouldn't it? Or unless it's 2 and 2. It's like some... Okay, so this board is kind of like some kind of like weird knockoff, I'm pretty sure. So it's going to take like a little bit more. There we go. Alright, so it fits in there. We're going to solder this up. And then again, we'll just probably do nothing with it after the fact. So I'm just waiting for my soldering iron to heat up now. Well, where's my chat box? Do I have a chat box? That should be something I have, right? Chat, there we go. I just have it sitting there because I know people don't want to come in here for this kind of stuff, but, we're just gonna go with it anyways. No. We want to just kind of... Okay, so... What you want to do is... I'm doing it wrong, but you should do the first all the way to the left and all the way to the right on each side. So you want to get two pins soldered the greatest distance from each other, and then work your way in. Well, then you can do whatever you want after you got the 2 in, but because that helps with figuring out kind of like where everything is. And it sets it in place so you don't have to, so it doesn't like wobble on you or do anything else. We're gonna throw in some music. We're gonna throw in... I gotta grab my... Oof. I gotta grab my thing, air filter, air purifier, the carbon collector, whatever you want to call it. I need it for soldering because it just it kind of just ruins the air quality when you solder. My music. And I got that in the background now, so that's going to be enjoyable. So let's throw on something. Let's throw something in the background to counteract that. With some stream beats. Ooh. Now the thing with soldering is you don't want to, you want to heat up the pin and have it hot, and then you want to put the solder on. Now, if any of you guys are watching this and want to do this at home, they come with pre-soldered. They got some pre-soldered boards for you, so you don't have to do what I'm doing right now. Come on. Come on. There we go. I think. Yeah. Right now, if I can get this to focus. You guys can see like all the little blobs of solder on there. That's fine. And you can see on this one the comparison between no solder and solder. Although I was doing a quick job on that. So we're gonna just touch some of these up, and then also finish up the rest. So another common question I get asked is how hot do you keep your soldering iron at? I'm at 560 right now. It all depends on how fast your soldering iron can heat up and just like stay heated even after it touches like a little surface. The surface, the pins. Like, you gotta know what you're comfortable with and how fast you can work versus burning the board or burning anything else, using that excessive heat. Like, you want it hot, but not hot enough to, like, burn anything. Alright, so now we got to rewire this. We're going to put our parts in. We're going to put... Let's do this one at a time. We're going to throw in... There. We got our sensor, sonic sensor. We're going to throw in our... pins. Alright, so gray is VCC, which is going to be 5 volts. Sorry, my head got in the way. 5 volts. Brown is going to be ground. So we're going to put ground in there. And these two are going to be 12 and 11. 11 and 12. Right there. So that's going to be... Nope. So that's going to be our sonic sensor right there. Oh. Which one is this? Sorry. There we go. Next is going to be our little... whatever... buzzer thing. Screaming buzzer with the plus sign on top. You want to put it in there like that, and then we're going to take our two wires. Now the wires, they can be whatever color you want them to be. It's just they're different in my case, in most cases, for these wires to be like different colors, so that way you can tell what goes into where, because normally like traces that are set out are kind of like they're already pre-made on like circuit boards and stuff, so you don't need to follow them, and you know where they are because there's a plan that tells you. But like right here, you're building your own circuit, so you can, like, you know, just like it doesn't matter, like you can screw this up kind of severely. Well, yeah, not severely, but you can screw it up to the point of where it's not gonna work, and then you gotta figure out where the problem is. So we decided, what, on 3 on this one, I think? Yep, that's fine. And so here it is. Let's test out. Okay, it's not really doing anything because it's still running the previous code, which is the one... What is this now? Yep, it's the on-off. And so now we're going to just have to write the code for it. So, onto the... what I hopefully think is... Arduino. Hey. Let's throw that over there. Throw my soldering stuff over here. And we're just gonna write this code up. File new. Alright, now let's bring you guys in with us. Woo! Screen capture. There we go. Alright, so now we've got our blank screen. Now, for time's sake, we're gonna cheat a bit, and we're just gonna grab the grab a code from here. Yes, just accept all. Control all V. Nope, that's not what I wanted. Are you seriously gonna... Alright, so we've got this code. Now we're going to go into nano, old bootloader, port. Oh, I undid it. Shoot. So we're going to use this as a base for... We're going to use this as a base for the code that we're going to write for creating a detection center for our tripwire. Yeah, tools, port, COM3. We're going to upload this. This is going to be tripwire sensor, ultrasonic sensor. Compiling, so it's compiling. Come on. Uploading, there we go. Oh, of course, it's going to do this thing where it freaks out. So, Arduino is not really the best program. It'll freak out. Come on. Compiling's good, okay. Alright, so we're going to have to undo that and plug it back in another USB port. Port, COM15. Upload it there. It shouldn't be having this difficult of a time. Because, okay, so if it was working normally, it would show you how much of a percentage that it's doing the uploading. So if it doesn't show you that, that means this program is bonk for right now. Yeah, let's try this one. Are you just a dead chip? Did I just put another dead chip on there? No, it can't be. It's another dead chip, isn't it? Well, I'm not surprised because I've had these for like a minute, but like, still like 2 of them. It's just like, what's going on here? All right, let's try another chip. Yeah, that's fine. Is it the wire? Or did you guys figure out how to over Arduino? Wait, are these the 166 megabyte? Nope, because it'll automatically say no. We're wrong code. Yep, wrong board for the code. It won't even communicate. Okay. Is it the cord? Oh no, it's done uploading. Okay. So let's try this one again. Let's try uploading with the one that's already on the board so I don't have to solder another one. Let me just grab another cord because I really don't want to solder another board and just toss this one. I know I got a bunch of these on like AliExpress and stuff, but like they should work. There's my damn one for that. There it is. Alright, so we're going to try this one more time with a different cord that I know works for sure. Alright, that's there. That's there. Alright, how we doing? Alright. Alright, let's try it again. Upload it. No, it wasn't the cord. Because normally these things could, you know, do what they gotta do with very quickly. No? No? Where is it? Tripwire. You gotta be f***ing kidding me. Alright, let's try and upload it to this one. Alright, so I brought back the new chip, or the one I just, yep. So I have two duds. You can see you saw the difference there. Nope. It should do it like flash, like really fast. But none of these are, so cool. back to the soldering station. Son of a bitch. I wanted this to be done in like 5 seconds. Now it's like dragging out to the ends of the world. Ugh. Where's the... Yep. We're going for... Boop, boop, boop. Alright, we're back to this stage again. So I gotta kick this one off, throw it away, because I am not in the mood for playing with this kind of crap. Ugh. They're about $3 a pop. Yeah, I know they're expensive, but like, at the same time, there's nothing I can do to fix them. I really have to design something for these other boards that I don't have. I have the parts for, but I'm like, I don't know what to do with them. So I gotta design a project for them. Because at this point, they're just going to waste. Do I have anything in here? In my parts bin? Come on, you. There should be a lot of these things in here because... Nope. Of course there aren't. Because there would never be anything I would need that I would put away for a later date. Oh wait, that is the right size, if I can... Yep, that's fine. And that's fine. Okay, I got 2 of them. There we go. I can put the rest of my pin bin away. Because I just have all these different kinds of pins for different projects that... For different boards that I have different Arduinos for, and there's just too many. Alright, let's just do this. Bring it up. Okay. Put it all away. And we'll figure this out right now. Okay. Come on, you. There. Come on. Force your way in there. Alright, so we've gotten to that point where I'm starting to care less and less about this project because it's just causing me more and more hassle. So that's there. That's there. With any luck. I said with any luck. There we go. There we go. So we should be almost done. Alright, so we're going to take out the soldering, the solder, and we're going to go for it again, because again, this is going to be our second try. Third try, technically. Second time soldering. Okay. Now we got... Okay, we gotta get all 4 corners first. Now, there we go. 1, 2, 3. You don't need that much solder on each joint, just enough to bridge the connection. You don't want a giant glob, but again, you'd want it to be good enough to where it'll bridge even if you like bump it or something. You don't want too little or too less. And so, oh, it looks like we got someone here. Mommy's milk. Huh. How you doing? Don't mind me. We're doing a little project here. We're creating a electric, well, I don't want to say electric tripwire, but like, yeah, an alarm for detecting people moving through hallways, I guess. Or you can place this on a windowsill if someone tries to come in or detects motion going in and out. You can have that too. So we're just... So I'm just trying to complete this. We got... This is our 3rd Arduino board because I had them for kind of several years now. And we've just started using them again. So after a couple years, they usually break down and they're not, well, especially if you buy them from AliExpress or Banggood or one of those other cheap Chinese knockoffs. But I don't have the money to buy, you know, bulk Arduino projects because they're like $40, $30, $15 a pop, and you can get 5, 6 of them for about $15. Just on like the just on the regular like Banggood websites, you can buy a whole bulk for the cost of like one regular Arduino project. Now if you can see, oh, here, I think my soldering's all good. Oh, wait, nope, missed A0. That's why I take a look at them. As you can see, A0 is not necessarily the best done, if at all. That's why you double check your work. Especially doing prototypes. You always want to make sure your prototypes work before you order stuff. This could get costly. And I do want to use this Arduino Nano for like other projects too, so I want to make sure the pins are all there, even if we don't use them today. This stuff interests me, but nothing I can study online. So, yeah. What do you mean, like a junior in high school, or like in college, or what are we talking here? So again, soldering, when you do this, you just want a little bit on there. You don't want too much. Like, that one's a bit too much on A2, if you look at it. Let's see where we go. Yeah, you can see it's a lot bigger than the other ones. That's a little bit too much, but I don't want to mess with it too much. The A0 and all the other ones are about right. The VN is kind of a bit off. Cybersecurity. Ah. Yeah. Studying like stuff like electronics, they like either throw you off the deep end with a lot of these things that I've seen. They throw you right off the deep end, or they with all the technical terms and knowledge, or they like really baby you, and you don't want to go through that. So I don't know. And if you're going for cybersecurity, you kind of need to know a little bit of both the physical product, and you need to know a little bit of the software side to understand how you're gonna do your things, how you're gonna protect cybersecurity and all that stuff. So anyways, back to the project. We got an ultrasonic sensor here. Now this shoots out ultrasonic waves out one of these and then collects them with the other. And because sound is a constant, it's used as a measuring form of how long it takes to go hit an object and come back. So they're using reflective sound. There are some things that can, always stop it from happening. So you got your let me just take that off now. Well, you got your ground, your echo, your trigger, and your VCC. The ground and VCC are basically how you power it. The echo is what shoots out, and the trigger is what is affected when it comes back in. We learn components, as in fixing computers and setting up servers, physical and software, firewalls, and also learn programming. We do Python, Java, JSQ. Well, yeah, that's basically all you need right now for becoming a cybersecurity major. That sounds about right. But sometimes there's a mystery that you want to learn more. So what we're doing now is we're going to start hooking up the sensor to the Arduino now that we've got it all soldered on. All the pins soldered on to the breadboard. So VCC, this thing takes 5 volts, so we put it in the 5 volt section. The ground is the brown, so we're going to put that into the ground pin. That one. And then these other pins, we can choose whatever pin we want to and then assign them later in the code. So we're just going to do 12 and 11 for them. Python I want to get into, by the way. I haven't, because it's easy to learn and it's got all these different libraries. That's what I want to do one of these days, is just like do a stream where I'm like kind of like watching someone and then kind of like replicate it, just so I can like, learn how to do it. Because I have a bunch of Raspberry Pis, and I swore to myself, every time I buy a new one, like a new one comes out, I'm gonna buy it and I'm gonna learn Python, and then I never do. And I know it's easy, I know it's super easy, but like I don't have the time to actually learn it. Java's a bitch. I'll tell you that. If you don't program it right, the memory leak from the program will crash. And that's a pain. So, what we're doing here now is we're getting this buzzer. This is a buzzer right here. I don't know if you can see it right there. But same thing you find on a motherboard usually for like saying, for it like outputting like, hey, something's wrong on the motherboard, and it'll beep or something. Same one. And so we're just gonna plug one wire to the top and one to the bottom. The plus side is always going to go to ground, so we're going to plug that into ground over here. If I could figure that out. And the other one, we're going to control the voltage going into it with pin 3. Hopefully that's pin 3. Yep, that's pin 3. And then let's see. Let's go. We got to swap back out. I got to turn off my soldering iron. And pray that this is the last freaking one that I have to do. So we can plug this in. We're going to go out of here. We're going to go to... What's going on here? Oh, we're going to detach this wire really quick because it doesn't know that there's a buzzer yet. And it'll, like, the pin isn't assigned anything yet, and sometimes they just freak out for, like, no reason. And I don't know if you can hear it. Let me turn my volume up. Too far. But if you guys heard that, sorry if that hurt your ears. But sometimes the pins will act crazy if you don't assign them properly. So we're gonna go into... And now it just freaks out for like no reason whatsoever. Okay. So we're going to go, where is it now? Boop, boop, screen capture. All right. So now we're going into the coding of this wonderful thing. And I say wonderful thing because I can't say it's a piece of meh. So, all right. So we're gonna, oh, nope, we're not gonna grab that. We're gonna grab file new, create a new sketch. Oh no, wait, we already have our old sketch. So this sketch, I just grabbed it from the Arduino website for ultrasonic sensors. And it literally tells you all the math and all the science behind the sensor. But we're just going to steal it. And, you know, if it works, well, it's supposed to work. Because I've done this before. So what you want to do is you want to set your pins that we have. Which were, what is it, 11 and 12. And 11 is trigger. 11 is trigger, and 12 is... should be... that. Okay. So, it's uploaded. Wait, we seriously uploaded it? Oh, thank God. Okay. So... this Arduino should be fine. Ugh. So, like, just getting the right thing. Yep, the clicking was the buzzer because it was not assigned properly to... so, it was assigned to, what was it, trigger pin number 3. So it kind of, the Arduino isn't smart. You have to physically program it to know which sensors are where and which pins they're using. The clicking was from, the buzzer was plugged into pin 3, and it was assigned to the trigger pin. So it was kind of doing what it's supposed to do. Just sending out little, it was getting feedback from the Arduino. So it wasn't working properly. Now with this, we can go to, because it has all these serial print stuffs in here, it literally transmits the data back here. So the ultrasonic sensor is, we're detecting 3 millimeters. So let's, okay, so we're here. Let me bring that to you. So like, if I put my hand in front of here, you see it goes like, ooh. Nope, you don't see it at all because, woo, we're going to throw this over here. So you see all the distances over here on this right here? Well, let's see, it's like 72 centimeters, something like that. Well, that's because my cord's in the way. It's kind of like fluctuating. But if I put my hand closer and closer, it reads it as 1 centimeters. And as I pull it further away, you can see it change with my hand, which is kind of awesome. So, like, this is how we're going to detect if someone's coming through the door. If this number changes right here, if this number changes, then that's what's going to set off the alarm. We're going to program it to set off the alarm if this number changes too radically. So that's what we're going to do. All right, so we're going to go back to, oh, yeah, it's freaking out because it doesn't know what I'm doing with it. All right. There we go. All right, so we're going to leave it at a comfortable 6 centimeter distance between an object as I reprogram it. So let's throw off the camera. We can throw off this. So now we're going to make a function, void sonic sensor. And we're going to just throw everything in here into this segment, so we can reuse this code over and over again and draw upon it as we wish. This is all in C++. Well, it's based on C++. So, like, oh, I should put that in there. Is there a thing for C++? Nope. You can't actually... Oh, wait, yes you can. C++. There it is. I don't know why it didn't come up. But, yeah, no. So that's good. Alright. Now this is going to be... You thought before was kind of time-consuming. Now it's going to be, like, ridiculous time-consuming for doing this part. I don't want that serial. And it just takes too long to boot sometimes when you have more code in there than what you need. Alright, so we're going to do this. We're going to call upon it every time. And remember to always check your work. The end syntax is always going to be, like when you want to end a line, it's always going to be a semicolon for C++. So always remember to do that before you go. In proper code language, you'd go to the next line after you complete something, but this will cause it to continue on to the next one if you don't have a semicolon there. Let's just see if this is working as this code. So I'm going to upload it really quickly. Yep, the function still works. Okay, so the function works. All right. The reason we're doing that is because we're going to make an array for this thing. Int. What am I going to do? What am I going to call it? Sonic average. Now, my idea is I'm going to take the first 5 signals that come back with a measurement, and we're gonna put them together, add them all up, and then average them together. Is there a way to just... Oh, there we go. I can make this bigger, can't I? This is awesome, actually, because I can't see that. No, we're not doing 6, we're doing 5. We could do 6. Average... for baseline. So the next thing we're gonna do, so we're gonna make that a function. Void sonic average calculation. So we're gonna do a for loop int I equals 0. I is greater than, so if I is greater than 5 or less than 5, keep doing it, and then when it's done, I plus add 1 to the I. So for that, so we're gonna do, so because the sonic sensor puts the distance, oh nope, the distance in out here is a major. Oh, what did I do wrong? This is why you make sure you check your work. Cause like stupid shit like this. For loop arduino, yeah. What is it? Oh, sorry, it's not a comma. It's a semicolon. And then I don't want F in there. Let's just check that one more time. Done. Okay, good. So now that we're there, alright, so what was I saying before I got interrupted? Oh, because, okay, so because distance is a global variable, it can be pulled into any function. So that's good for us because we're just gonna use sonic sensor, and then we're gonna throw in sonic average there, and it's gonna be replaced with I, so that way it can for loop all this so it can for loop kind of like just so it's gonna for loop all this stuff, but replace the number inside here, and we're gonna do that with equals distance. I forget if I'm supposed to put 1 or 2 there. That's why we're going to create another function. Void print out everything. So this is going to be our way to check all of our ins and outs. So we're going to do this, copy this, place this in here. And instead of do this, we're going to do something smart. It's going to be serial.print. So that's going to give us an out on our when we do our serial monitor, so we can literally see what's going on. I want to also make sure these don't activate during when I'm doing the check. Alright, so serial print. Actually, I'm just going to copy this. What am I doing? Why am I reinventing the wheel? Distance 4. Serial print. And we're going to go for sonic average I. Oh, no. Serial.print. This one's going to be I. For array number. And then that's going to be, okay, so it's going to be distance for array number, and then whatever number it's on. And then serial.print. We're gonna, the quotation marks allow for us to put a space in there and whatever else is highlighted. All right, so it's gonna be an average of there and there and there. Okay, so, and println means go to the next line. Print it and then end with an enter space, basically. So we're gonna try copy, print out everything. Oh, no, wait, we're gonna do sonic average first. And then do everything. So we're gonna upload this. Sonic Sensor was not... Copy. Is there something... Done uploading. Okay, so... Oh, this is in a for loop. And unlike, well, most codes... Okay, so we gotta auto-scroll this. Stops. What's going with the 2s and 3s? What? Is it really going to 2 and 3? What's going on here? Alright, so let's just, Sonic Sensor. And then undo these because, like, oh. Because I don't know what's going on. Are there really 2s there? Come on. There are no 2s. It's just a standard string of 6s. What's going on with this? Okay, so there's a 5 and a 7 there. Is it me? What's going on? I moved the thing back to 9. Okay, let's try and, you know what? Let's just keep that there and try and compare it. Yeah, no, these are all good now. What's going on? Okay, maybe... So there was a warning on some of these sensors that it just, like, freaks out. Sometimes for, like, being too close. Because the sound can reflect and stuff and do weird things because it needs to be a certain distance apart. Alright, so we're gonna assume that any window we're gonna try and, like, secure this with, or doorway we're securing this with, is more than 2 centimeters big. Alright, let's boop that out. Let's throw these back in. And let's upload this code and see if it does the same thing. And just leave it straight 9s. Besides, you know, the first one. Oh, what's going on here now? What's going on here? 0. 0's good. 9's good. Okay, so this is acting weird. Is it because it needs time to actually... Okay, so a lot of these things comes down to timing. So it could be that by deleting the serial prints, we're like deleting clock cycles that need to happen before the next sound pings back. So we're gonna finish this really quick. Oh, because if I just do this, it'll stop freaking out, right? Yeah, if I do that, it stops freaking out. So we're gonna leave. Okay, so we're gonna leave that code in there. All right, so we're gonna calculate it. Okay, so we're only gonna calculate this thing once. So we're gonna put it up here in setup. We're also going to give it a delay of 10 seconds. You know, 2 seconds every time it does it, so it needs 10 seconds to initialize. Hopefully that can work. All right, so start up distance calculation. All right. And we're just gonna do that. Two, 1, 2, 1, 2. Okay. And then, yeah, it's going to print out the same number over and over again because I didn't actually do anything else to that. Let's see if it does it after I do this. After the 2 seconds, because it could be a timing thing. I actually want to know what it is. Because, like, then I can properly... Okay, let me reset it. Oh, you're really gonna make me do this, aren't you? Because it won't... It'll... Oh, an Arduino broke. Good for me. Alright, so... Sometimes they crash and they don't know that you crashed, so we gotta get out here, go back in, file, open the thing we're working on, and hopefully did I brick another one? Oh. I bricked it again. What? How? How are these things bricking? Or is it? Okay. For fuck's sake. Okay. Oh, it needs to do the whole thing, so I need to wait like 10 seconds before it... Yep. Okay. And it looks like that 2-second interval stopped it. So I was right about it needing the time to... for the sound wave to come back and forth and stop echoing before it sends the next one. Which is what the serial print did. It gave it just enough time for it to fizzle out, for the sound wave to fizzle out before sending a new one out. Okay. Actually, I'm gonna put it back. Actually, what was up here before? Serial dot print ln. This is the beginning. All right. So let's upload this. And it should... There we go. Now we wait for 10 seconds. 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 16. There we go. All right. All right. So we're gonna do that. All right. So now that we know that that works, it places all the numbers into the. Oh. It places all the numbers. It places all the numbers in here. All right, yeah, it's got the 5 numbers that we need that we're going to use to average everything. So, we're going to throw this over here somewhere. I don't care. So, after that's all done, we're going to need a global integer sonic sum. I know it's not going to really be the sum. 0 calculated average. So sonic sum is going to be the calculated average of all those. So I can do something nice and fancy, but I'm not going to calculate this all, because at this point I don't want anything messing up. Plus that, plus that, plus that, plus that. Okay, so let's see if I got this right. So again, all arrays start with 0 in C++, because for some reason, especially I know the reason, I don't want to say it, but all European nations really like to start everything off with 0. 0, 1, 2, 3, 4. Alright, so sonic sum is done. Sonic sum. Print everything out. Actually, we're gonna do something really cheese. I don't know if it's cheese or not, but it makes everything a lot easier. For sum average for array numbers. And we're just gonna whoop that, and oh, average, forgot. I need to divide this by 5. Oh. Divide by 5. Okay. And I also forgot the semicolon, so let's see if this works. It's uncompiling. Throw this out. Serial monitor. This is the beginning. And now we gotta wait like 16 seconds because... whatever. No, what? Oh. Average for array number should be... Yep, that's fine. Yep. And this thing just keeps going because the printout is for here and for there, so that's fine. I should have just put it up here. Just so I can get that one time go. Because I don't want that interrupting some kind of clock cycle somewhere. And I'm thinking I should change it to like 1 second. Because I feel that setting it up for 10 seconds... It's not a true 10 seconds because I'm pretty sure there's some clock cycles that are lost. Yep, that's fine. As long as the numbers don't screw up here, that's fine. You know what, let's try and make it even smaller because I don't want to interrupt that many clock cycles. For this setup. Yeah, that's fine. Okay. Okay. Serial.println. Println. So I need to make a a delay in the beginning because we're gonna place this item down and hit reset just in case you touch anything. I don't want it to accidentally miscalculate something, so we're gonna put in a delay. Delay. Okay, so this is the beginning. Serial println. The delay is finished. All right, so we're gonna put delay here for about maybe, what are we doing? 3 seconds. Okay, so seconds are calculated in milliseconds, and you need 1,000 milliseconds for every second. So 3,000 is equal to 3 seconds. So let's try this out. Upload it. Because again, you got to constantly test when you're coding. Otherwise, it's not really coding. Delay is finished, and then, okay. There we go. And you know what? We're going to make that a constant int somewhere. No definitions are there. We're going to make changeable ints. Int beginning delay is equal to 3,000, just in case I need to, you know, come back and just be like, hey. Oh. Just because if I want to come back and, you know, just have something there. That's good. Okay, so we're good at... This is the beginning, delay is finished. Yep, okay, we got 3 seconds there, alright. So that's good. For now. Alright, so we got the delay in the beginning. The average. Now we just need a... So we're going to do an int trigger. Alarm. Now we're going to throw the alarm in here. So we're going to do... define alarm pin. Oh, we're going to name that 3. So... attach pin. Oop, nope. Trigger. I gotta rewrite these notes real quick. Echo for sensor. This takes forever to do. Alarm. Alright, so we're going for pin 3 is going to be the alarm. So that's fine. We need to make it a an output because you're sending a signal to the buzzer to get it going. Alarm pin output. Oh. Sets alarm to alarm pin as output. Let's verify that. We don't need to upload everything all the time. We just need to verify it. Alarm equals 0. Oh, I need to do that. So we're gonna have this as our trigger alarm. So if the trigger alarm goes to 1, it'll start. We're gonna make it go beep 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 or something. But if it's 0, it's fine. So we're gonna write the code in here now. We don't need this. So we got our, okay, so if we're gonna write a bunch of if code or if statements. If sonic sum is minus, we're gonna say what, 5 centimeters, 3 centimeters. We're gonna put it like an average here. So wait, okay, so we're gonna so like plus, or we want to do minus, plus, or you like have like this built-in average because it's an average. And if you go kind of like, sometimes the sensor might, screw up 1 or 2 readings, and you don't want to have a misreading with an alarm. So you kind of want to put it like, you want to add like, 3 centimeters. If there's a problem within 3 centimeters of it, we're good. So we're gonna have a tolerance. You want to have a tolerance for these things, because otherwise it could just like go off again for like no reason. So we're gonna, oh, this is gonna be set up here. So if we ever want to change any of our ints that we know where to put it. All right, so minus trigger tolerance. Oh. Is so if the tolerance minus that is less than wait, so okay, so the things we're gonna do, okay, so we're gonna grab a sonic sensor reading. So what we're gonna do, okay, so we got everything calculated up here. So in order to detect if a thing's working, you gotta first shoot the sonic sensor off. It's gonna calculate the distance. Then if the distance is less than the sonic sum minus the trigger, it will do something crazy like trigger alarm is equal to 1. If trigger alarm if trigger copy paste is equal to 1 is greater than 0. No. Is equal to 1. Oh man, I forgot how to do a output of just 1. It's under basic, it's under digital, it's basic. It's under blink. It would be yep. Digital right. Digital right there. But instead of so this one's, instead of doing that, we need to go up to grab the pin alarm pin, and it's gonna be high. We also want to copy, paste this up here and put it as low, because we want to make sure that it's off when we set it up. All right, so we're gonna test it. And I know you can't see this. We'll do that. We'll let you see it for the second time. Delay is finished. That is not what we wanted. Ow. Ow. Is it working? Yeah, it's working. It's working. Ah! Okay. So, like, the first one was kind of like, meh. Alright, so we're gonna set this up real quick. And that last one was because the power changed, so it did not send out the right the thing. So okay, so we're gonna yoink this, throw this here. All right, so we're gonna get set up for a live test to run, and let's go with Sony camera right there. All right, so here we go. Here's our wall. It's in between the sensor and that. Let's plug it in, because as soon as you plug it in, it will freak out. It'll set. It'll arm. What's going on? Oh, no, because I reset it. Okay. So that might be a problem. No, why are you freaking out? Why? What's wrong? What's wrong? All right, so it might be triggering faster. Okay, so I think I know what the problem is. I know what the issue is. I know what the issue is. Damn it. Okay, because it's that same stupid issue we had before. We need to have a delay in there. We need to have a delay in between here and here. So we're going to grab this delay. Copy. So every half a second, it's going to delay. All right, so we're going to try this without it freaking out. Hopefully. So okay, so we know it turns on and off, at least the buzzer. So we got that part done pretty good. And now, oh, it's done uploading. Let me reset it really quick. Okay, it's beginning. Wait, let me throw on the Sony camera. All right, so you can see this thing. You can see the sonic sensor. There we go. But as you can see, it wasn't as fast as before when I don't know if you saw that part, but it wasn't as fast as before. So I'm going to decrease the clock speed on here. We're going to make it 250 instead. All right. Let's look at that. Let's hit reset. And delay is finished. There. We're at 11. Again, that's kind of like really, let's see if we can kick it down to 100. That delay. And, oh, I forgot to check this thing. All right, so this is the beginning. Delay is finished. Average numbers, okay. And it's not freaking out. There we go. And once more. Hey! It works! We did it! Awesome. So, with this code, I'm going to put this code up somewhere. And so you guys can follow along. Hopefully you guys won't need like 3 Arduino Nanos for whatever reason. But, yeah. So, yep. So I'm gonna edit this down to take out all the bad parts. And then I'm gonna throw this all up on YouTube. So, I'm gonna go now. Like, share, subscribe if you're watching on YouTube later. And I'll have a parts list down below. Have a wonderful afternoon, evening, night, and I will see you guys next time. Bye. Ooh, yeah. As for